Assalamu alaikum wa rahmatullahi wa barakatuh. How are you, ladies and gentlemen? I am Miss Roshan from Eduverse. Today, inshallah, we're going to revise and we're going to take a very important tips about science, second term, grade 8. So let's see. First, let's talk about the units that we have here in our second term. We have periodic motion. We're going to talk about oscillatory motion and wave motion. The unit 2, sound and light. We're going to talk about properties of sound waves, wave nature of light, reflection and refraction of light. Unit 3, reproduction and continuity of species. We're going to talk about the reproduction in plants and the reproduction in humans. First, let's talk about the first unit, oscillatory motion and wave motion. Motion. We have two types of motion. We have the transition motion and periodic motion. Transition motion is only the movement of anything from a place to another. No direction, no time, no repeating motion. Now, what about the periodic? Periodic motion is a regularly repeated motion in equal interval of time. And inside the periodic motion, we have another two types. We have oscillatory motion and wave motion. What about the oscillatory motion? It's the regular repeated a motion in equal period of time around its rest position. Like, for example, this. I have this, my pendulum moving right, and left, passing through the rest point in the middle, and it's a repeated motion in equal interval of time. So here, yes, ladies and gentlemen, we have an oscillatory motion. So examples of the oscillatory motion, for example, the pendulum, the spring up and down, also passing through what? Passing through the rest point, and it's a repeated equal interval of time, in equal interval of time. Turning fork, also stretching string, motion of a swing. And we now already know what's the meaning of oscillatory motion and some examples of it. Let's talk about some properties we should know. Okay, first, amplitude, maximum displacement. We measure the amplitude with meter. Okay, complete oscillation for amplitude, complete oscillation, right, and left. Okay, complete oscillation. Periodic time, the time taken for the body we're talking about, for example, the pendulum, to complete one complete oscillation. And the measuring unit of the periodic time will be the second. Okay, what about the frequency? It's the number of complete oscillation in 1 second. Okay, and we measure the frequency, of course, by hertz. We should know this law. What's this law, yeah, Miss Roshan? It's the kinetic energy, guys. It's equal half times mass times V2, velocity to the power 2. You must know this law is very important. Kinetic energy, okay, equal 0.5 times the mass times the velocity to the power 2. It's direct relationship between the kinetic energy and the mass, and we have another relationship which is direct also between the kinetic energy and the velocity. Okay, but we have here, when we talked about the properties, we can find a relation between two properties, and the relation will be inverse relationship. Excellent, guys. It's between the frequency and the periodic time. They are reciprocal to each other. Here we have some conversions. We must take a look on them. For example, if I want to change from hertz to kilohertz, now I must to multiply it by 10 to the power, yes, -3. Excellent. So, and when we want, for example, to change from hertz to megahertz, we will multiply it by 10 to the power -6. Okay, so another tricky question. I want you to change from gigahertz to hertz, from the big to the small. So I will multiply it with 10 to the power 9. No negative here, because we're changing from the big value to the small value, times 10 to the power 9. Excellent, guys. Excellent. Okay, let's talk now about the wave motion, the second type of the periodic motion. Okay, we have the wave motion. We were going to talk about the types of the wave motion, what's the line of wave propagation, and we're going to talk about some properties also. First, types. We will divide the types to explain it and to be more clear to understand them according to what the ability of the wave to propagate and to transfer energy, and the direction. What about the direction? It's the direction of the vibration of the medium, okay, particle relative to the direction of the wave propagation, if it's perpendicular or it's parallel or in the same way. So concentrate with me, please. Let's talk about the type according to the ability of the wave to propagate and to transfer energy. We have here electromagnetic waves and mechanical wave. Electromagnetic, okay, we don't have any electromagnetic. All of them will be transverse, okay? And mechanical, no, we will have transverse and longitudinal. What about the electromagnetic? Electromagnetic is very easy, and it's can propagate in vacuum. They don't need a medium to propagate through. So what about the mechanical? No, they need a medium to propagate through. They cannot propagate through vacuum. What are the example of the electromagnetic, which they will be all transverse? We're going to explain transverse after 1 minute. Okay, for example, light, infrared, radio, and the velocity in vacuum or free space will be 3 times 10 to the power 8. Okay, they don't need a medium. Cross the medium. They can propagate in vacuum. So what about the mechanical? Mechanical, we have two types. We have some transverse and we have also longitudinal. They need a medium. For example, mechanical transverse like the water, mechanical longitudinal like the sound. They need a medium, ya shabab. Okay, let's talk about the another way that we can study the types of the wave by it. It's the direction. What's the direction? For example, we have already the wave propagate in a direction, and the medium particle, okay, they will vibrate perpendicular on the line of propagation of the wave, or they will vibrate parallel to the wave line of the wave propagation. If they're going to vibrate up and down, so they will be transverse wave, and we will have the highest point, we will call it the crest, and the lowest point, we will call it the trough. So what about the longitudinal? Here, the medium particle vibrate parallel all in the same time with the line of the wave propagation. And here we will have compressions, rarefactions, compressions, rarefaction, compressions, the area with a very high density and pressure, but the rarefaction, the areas with a very low pressure and low pressure areas, okay? Okay, and density, of course, lower density, lower in density and pressure. These are the rarefactions. Now, already we can differentiate between the types of the waves according to the ability of the particles or the direction of the particles according to the line of wave propagation. Okay, for example, the wave motion, we have a very important use here, which is the jacuzzi. We can use the concentric water waves with the hot water waves, and we can treat the cramps by them. And we can use the jacuzzi, the concentric water waves also, but the water here will be cold, and we can treat the nervous tension using them. Okay, let's talk about the properties. Do you remember the properties for oscillatory motion or the oscillatory motion? We were going to take the same, but we're going to add some other properties. For example, the wavelength. Wavelength, it's the distance between two successive crosses if we are talking about the transverse wave or two successive troughs. And if we're going to talk about the the wavelength for the longitudinal, we can say that it's the distance from the center of the compression to the successive compression, to the center of the successive compression, or it's the distance between the center of the rarefaction to the center of the successive rarefaction. And we can measure it by, yes, by meter. Okay. Another, we were going to take all these rules right now, but please follow me. The simplest law that we can find by the wavelength, it's the distance over the number of the wave. The distance taken by the wave over the number of the waves. Okay, what about the wave amplitude? It's the same like the last lesson, which is the maximum amplitude, the maximum displacement. We can measure it by the meter. The wave velocity, it's the distance covered by the wave in 1 second. It's the wave velocity. We measure it by meter per second, and we can find it by this law, distance over time, the distance over time. Okay. And now the velocity also, it's a very, very, very important law, which is the law of the line of the wave propagation. The law of the wave propagation, it's the velocity equal frequency times the wavelength. Velocity equal frequency times the wavelength. This is a very important law, ya shabab. Okay, let's talk now about the wave frequency. The wave frequency, the unit we're going to use here. Also, it's the hertz, which we can know it's low now. It's the number of the wave per time. It's the number of the wave per time. And periodic time, it's the time we can measure it. We can use the second as a unit, and we can find it by time over number of waves. Okay, some important numbers I want you all to know. The velocity of the sound wave through the air will be approximate 340 meters per second. The velocity of the sound wave through the water will be 1500 meters per second. And the velocity of the sound wave through the wood or anything solid, it will be 1850 meters per second. Okay. And now let's take another conversion here between meter, millimeter, micrometer, and nanometer. Here with the meter is the bigger number, is the biggest number here, actually. Okay, so if you want to change from meter to millimeter, I will multiply it by 10 to the power 3 because I'm changing from the large number to a smaller one. What about, for example, changing from micrometer to nanometer? We will also multiply it by 10 to the power 3, okay? The difference between each of them is 1,000. And for example, if I'm going to change now from nanometer to meter, multiply 10 to the power negative 9. Multiply 10 to the power negative 9 because I'm changing from a small number to the biggest number I have here. Okay, ladies and gentlemen. Yes, concentrate with me, please. Now, let's take some very important definitions. And while we are comparing between the oscillatory motion and the wave motion. Definition first, what is the oscillatory motion? It's the motion that is produced by oscillating body at the two sides of its original position or rest position. What about the wave? It is the motion produced as a result of the vibration of what? Excellence of the medium particle at a certain moment and in a definite direction. What is the complete oscillation? Complete oscillation. I said it before. Yes, excellent. Please concentrate. It is the motion of the oscillatory body when it passes by a fixed point on its path two successive times in the same direction. Now I can say that I completed one oscillation. What about the wave? The complete wave, it is the disturbance that propagates and transfer energy in the direction of propagation. Okay, amplitude. It is the maximum displacement achieved by the oscillating body away from its rest position when I'm talking about the oscillatory motion. What about the wave? Also, it's the maximum displacement achieved here by what? By the medium particles away from their rest position. What about the frequency? Both the same. It's the number of complete here oscillation produced by oscillating body in 1 second, but here it's the number also of complete waves produced from the source in 1 second. What about the periodic time? It is the time of one complete oscillation, and the time and the periodic time in the wave, it's the time taking to make one complete wave. Okay. What's the velocity? It's the maximum when it will be the maximum when the oscillating body bothers its rest position. Okay, so we can say we have here what? We have the maximum kinetic energy too. Because we said kinetic energy, direct relationship between it and the mass, and direct relationship between it and the velocity. The wave has a definite velocity along the direction of propagation. Okay, it's the minimum here when it goes far from its rest position, when we are talking about the oscillatory motion. Example for the oscillatory motion: pendulum motion, motion of spring, spiral spring, motion of turning fork. What about the examples of wave? As we said, sound wave, for example, as mechanical longitudinal wave. What about the light wave? As electromagnetic transverse wave. We don't have any electromagnetic longitudinal. We don't have it. All the electromagnetic waves are transverse waves. Motion of mechanical transverse water waves. Okay, ladies and gentlemen. Let's take some other comparisons about, for example, mechanical and electromagnetic. Mechanical, they need a medium to propagate. Electromagnetic, they don't need a medium to propagate. Mechanical, they don't propagate through vacuum, free space, but electromagnetic, they propagate through vacuum, through free space. For example, mechanical, they are transverse wave or longitudinal wave, as we said, but all the electromagnetic are transverse waves. What about the speed for mechanical? Their speed is relatively low compared with the velocity of the electromagnetic. For example, like sound waves, longitudinal, water wave, transverse. So what about the velocity of electromagnetic? They have a very great speed. For example, when I'm talking about the light, it will be 3 times 10 to the power 8 meter per second. We have examples for the electromagnetic, like the light wave, radio wave. We use it in radars, for example. Okay. Point of comparison, let's compare between two other types of waves, which are transverse and longitudinal. The definition here: transverse, it's the disturbance. We know, we should, all of you should know that the wave, it's the disturbance happens, in which the particle of the medium vibrate perpendicular to the direction of the wave propagation. For example, the wave is moving like this, and the vibration of the particle will move like this. Okay, this is the transverse. They consist or compose of crust and troughs. Examples like the water wave, for example. So let's talk about the longitudinal. The longitudinal, it's also the disturbance in which the particle of a medium vibrates along of the direction of the wave propagation, which is like this, for example, the line of the wave propagation, and the particles also will move in this direction along the line of propagation of the wave. They are composed of compressions and rarefactions. Okay, examples, the sound waves. Important notes, important laws. Please concentrate. Important law number 1. Complete oscillation includes how many amplitudes? We have 4 amplitudes in one complete oscillation. Periodic time, it's very easy. It's the time. Okay, we are talking about periodic time. Put the time up. Periodic time, put the time up. Time in seconds, of course. Over what? The number of complete oscillation. The number of the complete oscillation type. And we can get it from another way. It's the time of one amplitude times 4, because we have 4 amplitude to complete one oscillation. This is very logic. But what about the frequency? The frequency means the number. I want to know the complete number of oscillation or complete number of waves. So number is up. Number of complete oscillation over time in second. We have inverse relationship between the frequency and the periodic time. They are reciprocal to each other, so we can conclude that frequency equal 1 over the periodic time, and we can also say that the periodic time equal 1 over the frequency. Okay, so frequency and periodic time equal 1 times periodic time equal 1. Let's talk about the wavelengths. The general law, as we said before, it's the total distance covered by the wave over number of waves. It's the total distance over number of waves. Total distance over number of waves. The measuring unit will be by meter. Okay, we have two types of waves. And for example, if we want to find the wavelength of the transverse wave, it will be equal 2 times the horizontal distance between what? Between the successive crest and trough. It's the midway. We said in the definition that the wavelength of the transverse wave is from what? From the distance between two successive crests. So here we are saying if you have the distance between the crust and the following trough, So here we are talking, for example, let me make it more clear for you. If I have here this wave, okay, this is the crust and this is the successive crust. So they are telling you that we have the distance between the crust and the trough after it. So we have the mid distance. We are in the middle between the wavelengths. So if you have this distance, you will multiply it by 2 to find the other part. So you have now the all the wavelengths. Here when we are talking about what? About the transverse wave top. We have another law when we are talking about, for example, the longitudinal wave. It's also the same idea. If you have the distance, for example, let's do it like this. This is compression and this is rarefaction. This is another compression. And this is another rarefaction. If you have the distance between horizontal distance between the center of the compression to the center of the next successive rarefaction. Is this the wavelength? No, it's not. The wavelength is between the center of the compression to the center of the successive compression. So as we said before, here we have only the half the distance. So if you have this distance, you multiply it by 2 to find this whole distance, this whole wavelength. I hope that everything is clear for you, ladies and gentlemen. And now let's talk about the following laws. For example, the wave amplitude. Okay, it's the maximum displacement. Okay, here, if you have a problem that for example, let me draw one more graph for you. They will give you, for example, the distance from this crust to the trough, but this distance will be vertical. If you have this vertical distance, so where is the amplitude? I need only this. This is the amplitude, only one maximum displacement. If you have all of this distance, so you have the whole distance, I will divide it by 2 to find only this part, the amplitude I need. So wave amplitude equal the vertical distance between the crust and the trough of a wave. We measure it, of course, by meter divided by 2 to find only the amplitude. We can say that here we have two amplitudes. So multiply this value by 2 to get only one amplitude. What about the wave velocity? As we said, we have more than one way to get the velocity of the wave. First, the general law, which is the distance covered by the wave in meter over time in seconds. Distance over time. We have another law, and it's very important, which is the law of wave propagation, as we said, which is the frequency times the wavelength. Velocity equal the frequency times the wavelength. So let's get that checked together. What is the relation between, I'm talking about here, the last law. What is the relation, for example, between the frequency and the wavelengths? Inverse, excellent. And this is the graph representing the inverse relationship between the frequency and the wavelengths. What about the relation between the velocity and the frequency? Direct. Excellent, ladies and gentlemen. Lovely students. Excellent. Now let's see the last relation, which is between the velocity and the wavelength, and it's also direct. relationship. So the only inverse relationship here we have between the frequency and the wavelength. Okay. Let's solve some questions quickly on Unit 1. For example, study the opposite figure, then answer the following questions. For example, point A. Where is A? Here is A. A, it's what? It's what? The rest position. Excellent. The rest position. Rest point or position. Type. The distance between A, B represent the distance between where? A, B, A, B, A, B. It represents what? It represents the one amplitude. Amplitude, of course, excellent. And it's equal to what? We have many answers here. Yeah, for example, we can say it will be equal the distance between B and A. And it's also equal A to C or C to A. We have 4 equal amplitudes in one complete oscillation. So the distance between them, they are all equal in distance and in time too. Excellent. So we can say, for example, let's write C, for example. Now, the vibration body has its maximum kinetic energy. Maximum kinetic energy. Please concentrate. We should find what here. What is the relation between kinetic energy and this pendulum? It's the velocity. Excellent. Where is the maximum velocity? And you can find the maximum kinetic energy at the same point, which will be also at A, which is the point A. It's the rest point or rest position. When the pendulum, let's solve some problems. When the pendulum makes 300 complete oscillation, number of complete oscillation here I have 600 complete oscillation in 2 minutes. Minutes? No, I prefer to change it into seconds. Its frequency equal? What is the law of the frequency? What is the law first? It's the number. I said frequency is the number, so I will put the number up. Number of complete, okay, oscillation over what? Over time taking. So number of complete oscillation, it will be 600 over the time taking. Now I can't leave it like this. I should change it into seconds. 2 minutes. Yes, it contains how many seconds? I will 2 times make like this. 2 times 60. So it will be 120. So the answer will be excellent. 5 hertz. Don't forget the unit. And it's periodic time. And it's periodic time. We have 2 ways here. If you want to use the periodic time law, you're going to put the time up. So it will be 120 over 600. Or we have another way, and it's very easy, the reciprocal to each other. Periodic time equal 1 over the frequency, and I have the frequency here, so I can say that it's 1 over 5. The periodic time will be 0.2. Periodic time 0.2. What? Let me hear. Seconds. Excellent. Love you guys. Another problem. Calculate periodic time and frequency for an oscillating body that makes 300 complete oscillation in what? In half minute. Half minute. So let's solve it together. Calculate periodic time and frequency for, let's talk about, for example, let's do what? What do you think? Let's do, for example, first the frequency. Let's do the frequency. Yellow. Okay, it's what frequency? It's number. So I will put the number up. It's the number of complete oscillation over the time taking. The time here is minute. No, I don't prefer minute. I love the seconds. So half minute here. I have how many seconds? Yes, minute contains 60 seconds and half minute. This means 30 seconds. So here I have 10 hertz. I found the frequency. What about the periodic time? It's very easy. As we said up, we can use its rule, or we just can find the reciprocal from the frequency, which is 1 over f. So it will be 1 over 10. I have 0.1 second, and this is the periodic time. I love solving problems. Okay. This is very good one and very, very clever. The longitudinal wave is produced by a spiral spring such that the distance between the first and the fourth rarefaction is 18 centimeter. Okay. Okay, find the velocity if the frequency of such wave is 20 hertz. Type. Okay. First, I can know from this problem the number of complete waves. I should know the number of the complete waves first. Why? Because they want you to find the velocity and they gave you the frequency. Which law we can use here? Which law? Yes, I can use the velocity, the law, yes, excellent, the law of the wave propagation, which is the velocity equal the frequency times the wavelength. We need the velocity, we have the frequency, we need to find the wavelength, and we can find it from here. But please follow me. Type. I have a rule that's telling me the wavelength equal the distance covered over number of waves. Okay, the wavelength equal distance over the number of waves. Type. Distance here we have 18 centimeter, 18 centimeter. And how many waves? How can I find them? How can I find the complete number of waves between the first and the fourth rarefaction? Okay, this is very easy. Fourth means 4. The first means 1. So you take the large number, subtract it from the smaller one. So I can say that 4 minus 1, I will have 3. This is the number of the complete waves. Yes, this is very easy, I think. It's 18 over 3. 18 over 3. It's the distance over the number of the complete wave. And the answer will be 6. And the answer will be 6. Okay. Yeah, here I can find that this number will be by centimeter. The wavelength, I prefer it by meter. So let's change it to meter. It will be 0.06. Okay, now I have the wavelength by meter. Okay, so now, yes, I can find here the wavelength and I already have the frequency. Let's find the velocity and it will be very easy. Frequency, which is equal 20 times the 0.06, and now the velocity will be 1.2 meter per second. Yes, I'm very clever today. So let's complete. This is very good problem. Please concentrate. From the opposite figure of a water wave, calculate first the amplitude of the wave. The amplitude of the wave. Let's find the amplitude. It's very easy. I can say that it's what? Yes. How can I find it, ladies and gentlemen? How can I find it? It's the maximum displacement. Let me change the color. Okay. Let's go. So the amplitude will be 3 centimeter. Excellent. And then, they want me to find the periodic time. Where is the periodic time? It's the time taking to complete one wave. How can I calculate one wave? Here, one wave, I have 4 amplitudes. This is 1, this is 2, this is 3, and this is 4, and this is the periodic time, because here is the time. So the periodic time will be 4 seconds. Wave frequency, the wave frequency. How can I find the wave frequency? I'm not going to think a lot. It's the 1 over the periodic time. So I have the periodic time. So 1 over the periodic time, and it will be 0.025. If you want to find the number of the complete wave, divide that by the time, you're going to find the same answer here. It's another way to find the frequency. Wavelength. Wavelength. How can I find the wavelength? Let's check together. The wavelength, I can find it by the distance over the number of complete wave. I have here 8 and 2, so the answer will be the complete wave, the distance covered by the complete wave. So I have 8 over 2, 8 meter over 2, the number of the complete wave. So the answer will be 4 meter. The answer will be 4 meter. And the last thing, wave velocity. How can I find the wave velocity? And please concentrate. I already have the frequency and already have the wavelength. What's the name of the law that I'm going to use? It's the law of the wave propagation. Velocity equal frequency times wavelength. Frequency equal 0.025 times the wavelength, which is equal 4. And the answer will be, يا شباب, 1 meter per second. This is the velocity. Okay, I hope that's everything clear. And let's talk about, or let's zoom in on the second unit. Excellent. Second unit here, it's the sound and the light. Sound and the light. We're going to talk about the sound and the light. First, the sound, okay, it's the mechanical longitudinal. It's mechanical longitudinal. We can find the light traveling in all direction, okay, in the form of spheres, compressions, and rarefactions, because it's a longitudinal type of wave. The velocity of the sound, in the air will be 340 meters per second. And we also will going to complete with our laws, which is the law of the wave propagation, which is velocity equal frequency times the wavelength. We will going to have the same law here too. Right. Let's finish كده very, very important part in this lesson, unit 2, lesson 1, which is the type of the sound. We have infrasonic, sonic, ultrasonic. The infrasonic, the range of the sound frequency in this category, it's from or less than 20 hertz. And as a human, we cannot hear it. So what about the sonic? It's the range that we can hear as a human. It's between 20 hertz to 20 kilohertz. So what about the ultrasonic? Ultrasonic is more than 20 kilohertz. And if we are talking about the human, no, we cannot hear it. The ultrasonic is very important. And we can use it in different fields. For example, like the medical field for kidney stones, diagnosis of the tumor of the prostate gland, industrial, like for sterilizing of the water, food, or the milk, a lot of usage in sterilization of different types of for, as we said, like the food, like the milk, like the water, because it can stop the production of more than one type of a bacteria inside these materials. So the last field is the military field, and we can use it to discover the landmines. Okay, let's look in deep شويتين كده for the sound. For example, we have properties of the sound. How can our ear distinguish from different sounds coming from different things or people or animals even? First, we have 3 different properties. The first, we can call it the sound pitch, and the second will be the intensity. The third will be the quality. Let's talk about the sound pitch. We have, for example, the sound of the woman. We can call it, have a high pitched sound. Okay, it's sharp. It's sharp, okay? Type. What about the low pitched sound? As you can see from, you can hear from me. Sorry, it's a low pitched sound, like the man. Low pitched sound, it's a harsh sound, okay? Type. When we are talking about the sound pitch, we should know who is the antime of the sound pitch. Antimo. Who's antimo? Huh? It's the frequency. Excellent. I have high pitched sound, so I have high frequency. What's the meaning of frequency? It's the number of the complete waves per 1 second, okay? By, for example, any source that produce waves, okay? Type. What about, for example, the low pitched sound? So it will have what? Low frequency. Okay, for example, another example for the high pitched sound, it's like the sparrow. Another example for the low pitched sound, it's like the lion. Type. So we should always remember the relation between the pitch, or the sound pitch, and the frequency. Okay, they have direct relationship between each other. And how can I find any unknown tone? If I heard any unknown tone and I want to know its pitch, is it high or low? So we have what? We have Sievert's wheel. Excellent, guys. We have the Sievert's wheel. We can use the Sievert's wheel, knowing the frequency, and finally we can get, or we can find, or we can know the pitch of the unknown tone. But what is the law of Sievert's wheel? And it's very important. It's equal, the frequency equal number of cycles or turn times the number of the teeth gear of Sievert's wheel over the time taking, Let's talk about the second property, which is the intensity. If this sound is weak, like whispering, or strong, like shouting. Okay, first we have 5 factors affecting this sound intensity. Yani, for example, the amplitude here. The amplitude and the intensity, they have a direct relationship between each other, but it's not also only the amplitude, it's the square the amplitude. And we have another antene here, the intensity and the amplitude. Okay, so as we have a high amplitude, we have also a strong intensity, and if we have a low amplitude, we have low or weak sound intensity. So again, sound properties, we have 3: pitch, intensity, and quality. The pitch, it's direct proportional with the frequency, and it's the anthem of the frequency. But what about the sound intensity? It's the anthem of the amplitude, or square the amplitude, if you want me to be more clear. Another factor, it's the direction of the wind, and here we have inverse relation between the sound intensity and the direction of the wind. How? If you are moving in the same direction with the wind, if the same direction of the wind, the sound intensity will increase, but if we move in the opposite direction of the wind, the sound intensity will decrease. The third factor that affects the intensity, we have the area of the vibrating surface. And here we have a direct relationship between برضو area of the vibrating surface and the intensity, as we can use the resonance box. The resonance box, we can increase the area of the vibrating energy, and we can hear a very strong sound intensity. What about the fourth factor, which is the density of the medium? What do you think? If we increase the density of the sound, the density of the medium that the sound travel in or propagate through, what we can find? Yes, increasing in the sound intensity, the sound will become more stronger. So we have another direct relationship between the density of the medium and the sound intensity. As we increase the density of the medium, the sound intensity will increase to become stronger sound. What about the distance and the sound intensity? It's very important. This factor is very important. Okay? Please concentrate and try to imagine with me. If you are moving away from the sound source, what will going to happen? The sound will become less intensity. So we have here what? Increasing the distance, decreasing the sound intensity. We have an inverse relationship between the intensity and the distance. Only between the sound intensity and the distance? No, between the sound intensity and square the distance. And from here, from this factor, very important factor, we can get out the law, which we call it the inverse square law of sound. The inverse square law of sound. Okay. Let's talk about another part of the sound intensity. We have the scientist, which is called the decibel. Decibel discovered that we have a lot of varieties between different ears, different levels of sound intensity. So he discovered, or he decided to make another scale, and he called it decibel scale. And this is the scale of the noise. And we when we use that scale of the noise, we can use the unit, which is decibel also. But when we are talking about the sound intensity, no, the unit of the sound intensity, not the level of the sound intensity, not the noises, noises or the level of the sound intensity, we can use the unit called decibel. But when we are talking about the intensity, we can use only the unit which is called watt per meter square. Watt per meter square. Type. We can avoid the hazards of these noises by using what the ear plugs, which is made from silicon, and we can find it in any pharmacy. Type. The third property of the sound, which is the quality of the tone. How can we differentiate between two sounds that they having the same frequency and the same amplitude? Yes, from this property, which is the quality. Okay, in the tones, we have two different tones, which are the harmonic tone and the complex tone. Let's talk about them quickly, very quickly. What is the complex tone? The complex tone is composed of two tones, the fundamental, the basic tone, plus harmonic tone. This harmonic tone differ from one source of sound to another source. So this harmonic tone, which differs from the sound, make the sounds differ from each other, coming from different sound source. Both of them, fundamental, harmonic, will give out the complex. Okay, the harmonic tone will be always greater in pitch and lower in the intensity. From where? From compared to what? Compared to the fundamental tone. Important laws. This part we have important laws too. First, we talked about the sound frequency, which is the end theme of the sound pitch. And we have here the Sivart's law, which is number of cycles, number of distance, the number of rotations, okay, times number of ear teeth over time in seconds. Sivart's wheel is used to determine the frequency of the unknown tone. What about the speed of rotation? Speed of rotation, it's the distance over time, but here we can use the number of rotation turns over the time. The inverse square law of sound, and it's very important, it's the relation between the sound intensity and the inverse relation between it and the square distance. I, this represents the sound intensity, which is inverse proportional with what? With square the distance. Okay. And here also the law of the wave propagation is with us, which is velocity equal frequency by hertz times the wavelength by meter, and will give out the velocity meter per second. Some important definitions about the first lesson in Unit 2, which is sound. What is the sound? It is an external factor or stimulus that affects the ear, causing the sense of hearing. تمام? It's all تمام. كله تمام. يلا بينا. Sound velocity. It is the distance which is covered by the sound wave in 1 second. This is very logic. Sound velocity, distance over time. So it's the distance covered by the sound wave in 1 second. Sound pitch. It's the property by the ear that can distinguish between what? Rough, harsh, and sharp voices. This is the difference between rough and voices. What about the sound intensity? It's the property by which the ear can distinguish between sound either strong, I'm shouting, I can't shout now, shouting, or weak sound like whispering. Okay. Sound quality or type. It's the property by which the human ear can distinguish between different sounds. As I said, according to the nature of the source, because here the harmonic tone will differ from each source, even if they are equal in intensity and pitch. Type. What is the inverse square law of sound? It's the intensity of the sound at a point is inversely proportional with the square of the distance between the point and its sound source. What's the complex tone? It's composed of what? Fundamental, the basic, the tone associated with another tone, higher in pitch, as we said, but lower in intensity, which is known as what? The harmonic tone. So the complex tone composed of the two, fundamental, basic tone, plus the harmonic tone, which is always a higher in pitch and lower in intensity. This harmonic tones, this the most important part, which from this tone we can differentiate between, for example, the violin or the sound coming from the piano and the violin coming from the the loudspeakers and the drum. Okay. Type harmonic tone. They are tones that accompany the fundamental okay, coming with, accompany, a friend with the fundamental or the basic tone, but they are higher in pitch and lower in intensity and differ from one instrument to another. Okay, now, oof, take your breathe. Take a breath. Okay, let's start the light. What is the light? What is the nature of the light? First, I should know the nature of the light. It's a transverse electromagnetic waves. Okay, type. It's the light. It's an external factor which affects the eye, causing the sense of vision. This is the light type. What is the speed of the light? The speed of the light, as we know, it is the distance covered by the light in 1 second. And in the free space, this velocity will be 3 times 10 to the power 8. This is the speed of the light. And now let's talk about the first, before starting talking about the visible light, let's talk about the energy, the photon energy. We also have another scientist who wants to add anything to the history. So he said that I will say that in the amount or some amount of the light, I will call it the quanta, the quantum, and we can say, we can call them also the photons. So the energy, and as we know that the light is one source and one kind of energy. So this quanta, this photon, this some quantity of the light, the energy of this quantity, I will make a rule for them, and I will say that the photon energy equal Planck constant, which it's the name of the scientist. It was it's called, he called his name was Planck, Max Planck, and he added this constant, which is Planck constant times frequency. Okay, as we said, as he said, that we have a direct relation between what? Between the photon energy and the frequency, between the energy of the photon and the frequency of the photon. So photon energy equal Planck constant times frequency. And we have, don't forget this, this is very important, we have a direct relation between the photon energy and the photon frequency. Okay, right. Let's now talk about this specially visible light, the light that we can see. It's the one of the components of the electromagnetic spectrum. As we said, the light is transverse electromagnetic, and the range of the electromagnetic, it's in the range we have, for example, the infrared, the ultraviolet, and the visible light. This visible light, the range of it inside the electromagnetic spectrum will be between 380 to 700 nanometer. The wavelengths will be from 380 to 700 nanometer inside the what? The electromagnetic spectrum. Okay. And here we said that we have a direct relationship between the energy and the frequency, photon energy and the photon frequency. So let's complete this part, and we're going to summarize all the information about the light in this slide. The last thing I want to talk here about in this slide, it's the inverse square law of light. The inverse square law of light, we talked about this law before, but we used the sound instead of the light, and we have what? We have the intensity, the brightness of the light will be, okay, inverse relationship with the square of the distance, okay? And we call it the light intensity, not the sound here, but this is the light intensity, which is the brightness. Light intensity, it is the quantity of the light falling perpendicular to a unit area, of a surface in 1 second. If you are standing here, the quantity, the amount of the light falling on the unit area, you are the unit area, that's the quantity of a light will fall on in, and you are the surface area, the unit surface area, the light will fall on in 1 second. And by this, we can understand what is the light intensity, the brightness of the light. As it will increase, so the distance will decrease, because we have, or we can say the square of the distance will decrease, because we have an inverse relationship between the light intensity and what? And the square of the distance. Right. Let's revise this slide. The light nature, we talked about its transverse electromagnetic, the visible light, which is one of the components in an electromagnetic spectrum. The wavelengths of the visible light, it's between 380 and 700 nanometer. the speed, it's like any speed. When we are talking about any speed of anything, it's the distance over the time. So when we are talking about the speed of the light, it's the distance covered by the light in 1 second, 3 times 10 to the power 8 meter per second in free space. We talked about the energy also. Max Planck find a relation between the photon energy and the photon frequency, and this is the law that Max Planck discovered for us. It's photon energy equal Planck constant times frequency. And we can find that we have a direct relationship between the photon energy and frequency. And finally, we talked about this light intensity, and the light intensity also, we apply the inverse square law of light here instead of the sound, which is light intensity is inverse proportional with the square distance. The light, okay? We have some properties for the light too, or some points we were going to talk about the light in. So first we talked about the nature of the light. Let's talk about the splitting of the light. Splitting of the light. What is the splitting of the light? It's the analysis of the white light into this, into the analysis or splitting of the light into 7 spectrum colors. We can call it the 7 spectrum colors. So again, analysis of the white light, it is the splitting of the white light into 7 colors called spectrum colors. Okay, by using what? By using the prism. By using the prism. Okay. Yani, for example, I love to tell you this. You can use the word roy. Roy Gibiv. Roy Gibiv. It's the first letter of each color in their order. Yani, for example, this is red, orange, yellow, green, blue, indigo, and violet. So when the white light passes through the prism, it will give out the 7 spectrum colors, which are red, orange, yellow, green, blue, indigo, and violet. And when they are coming out from the prism, we should know three properties. We should take a look for the angle of deviation, the frequency, and the wavelengths. We can find that from at the top of the prism, very close to the apex of the prism, it's the first light will going to come out. It's the red one, which has the lowest deviation, and here the deviation is direct proportional with the frequency. So lowest deviation, lowest frequency, but the highest wavelength. Okay, and this will going to decrease or increase. For example, as we are talking about the deviation and the frequency, they're going to increase, but the wavelengths will going to decrease until we reach to the violet. So at the violet, we're going to find the maximum deviation, maximum frequency, and the minimum or the shortest wavelength. Okay, this is very important, ya shabab. And don't forget, we have a direct relationship between the deviation and the frequency, and we also have a direct relationship between the frequency and the energy, photon energy. Okay. Type the behavior, the ability of the light to pass through different mediums. Okay, different media. For example, we have 3 different media. We have transparent, semi-transparent, or translucent, and opaque. Transparent, it's like the air. The light, or most of the light, are going to pass through this material, and we can see the things very clearly through this transparent mediums. What about the translucent? It will absorb some of the light and will going to allow or permit some of the light to pass through it, so we can see less clearly than the transparent, like for example the tissue paper or the frosted glass, for example. The opaque, no light will going to pass. This media will not allow any light to will not permit any light to pass through it. So it's we cannot see through it. We cannot see anything through it. For example, I want you to, I will read it for you very quickly. It's a comparison, it's a table to understand more what's the transparent medium, translucent, or opaque. Transparent medium permits, as we said, most of the light to pass through. Object can be seen clearly through it, like air, glass, cup of water. What's the translucent or semi-transparent medium? Permits only a part of the light to pass through and absorb the remaining part. Objects can be seen through translucent media less clearly than the transparent one. For example, tissue paper, flint, or frosted glass. Opaque medium does not permit light to pass through. Object cannot be seen through opaque medium. For example, foil, paper, milk, wood, and cartoon. Light. Here we're going to start the third lesson in unit 2, which is the light what? Light reflection and light refraction. And it's a very interesting part for me. I love this part. Okay, light reflection. We have two types, regular reflection or irregular reflection, which is regular. For example, where these types will change according to the reflecting surface. Yani, for example, if the light were going to fall to incident on the plan mirror, for example, or aluminum or smooth surface, it will going to reflect all in one direction. But and now we can call it's a regular reflection. What about the irregular reflection? It's when the light falls on the reflecting surface, which is like the piece of paper. It's a rough surface, like a piece of leather. It's as we said, it's rough, so the light will be reflected in different directions. Okay, if we have a rough surface and the light will be reflected in different directions, so we have irregular reflection. If we have smooth surface, the light will be reflected in one direction, so we have regular reflection. Source of light. We were going to talk about the source of light, reflecting surface. Okay, and let's talk about the light reflection and the laws of the light reflection for now. First law, the angle of incident will be equal the angle of reflection. The second law, which is the incident, reflected, normal, all perpendicular on what? On the mirror, and all are placed on one plane. Okay, so the incident, the reflected, and the normal, all of them, and the points of incidence come in perpendicular to the mirror, all placed in one plane. Type. What about, let's take a very quick tips about the light refraction, which is the ability of the medium. Here is انكسار الضوء. Light refraction, this will be dependent on what? Dependent on the ability of the medium. The ability of the medium. So every medium will going to have a different optical density. So we have a term, we can call it optical density of medium. What is the absolute refractive index? The absolute refractive index, it's very easy. It will be the velocity of the light in the air, up, okay? And the velocity of the light through any other medium will be down. And it's a very important note. The velocity of the light through the air will be always the highest value compared with another mediums like the glass or the water. So we have also we always have the larger number up and the lower number will be down. So the value of the absolute refractive index will be always greater than 1. So what's the absolute refractive index of a medium? It is the ratio between the light velocity through the air to the light velocity through another transparent medium. The law is velocity of the light through the air over the velocity of the light through the other mediums. What about the law? If we have, for example, let's see it by drawing, it will be better. I'm going to show you a very good thing now. Let's revise كده the concepts of the light reflection. First, light reflection is the rebounding, انعكاس, returning back of the light waves in the same medium. I'm talking all here, all this is happening in the same medium, which is, for example, it's the air on meeting a reflecting surface. Okay, let's see. The light falling on the reflecting surface, this is the reflecting surface. The light falling, we can call it the incident ray. And the point here, when the incident interface with the met with the reflecting surface, we can we can call it the point of incidence. And we can draw here an imagining line with the red, and we call it the normal. The light will be reflected, and we can call it the reflected ray coming out, bouncing away from the reflecting surface. The angle between the incident ray and the normal, we can call it the angle of incidence, and the angle between the reflected ray and the normal too, we can call it the angle of reflection. What will happen? What do you think if I will, for example, place here a torch perpendicular to the reflecting surface? The light will come out from the torch, falling perpendicular on the reflecting surface. What about the reflection will happen? Yes, reflection will happen, and it will reflect on itself. Okay, so what about the angle of incidence and the angle of reflection? We don't have angle of incidence or angle of reflection because we don't have any angle between the normal and the incident light ray. All are on each other. Yani, for example, here I have, for example, this line falling down. It's the incident ray. The light that coming out, it's the reflected ray, and also the normal. You can find it below both of them. So we don't have angles. So what about the reflection? Yes, it will happen. But what about the angles? Both will be equal to 0, because the first law that the angle of incidence should be equal to the angle of reflection. So both will be equal 0 here in the reflection. So incident light ray, which falls perpendicular on the reflecting surface, reflects on itself because angle of incidence equal angle of reflection equal 0. What about the refraction? Okay, let's see. This is also, we can call it the incident light ray. This is the intersect between the two different mediums. We have here, for example, the air, and we have here the glass, and we draw our normal. Here is the reflected ray first, the refracted light ray. The angle between the normal and the incident, we can call it also the angle of incidence. The angle between the refracted light ray and the normal, we can call it the angle of refraction. In the next interface between the glass and the air, the light is coming out from the glass, going out through the air. This light, we can call it the emergent light ray, and this point will be the point of emergency. The angle between the normal and the emergent light ray, we can call it the angle of emergency. So this is the point of emergency, this is the angle of emergency, and this is the emergent light ray. Light refraction, it's the change of the light path, changing in the direction when it travels from the transparent medium to another. But what should happen here? Two transparent medium differ in their optical density. Law of the light refraction. Please concentrate. Here, I'm going to move from the air to the glass, The air, I have the air with a low optical density. الair مش زحمة. الناس اللي فيه مش كتير. Okay, so it has low optical density. طيب، أول ما يخش على الجلاس, very crowded place, high optical density. I should stop. I will decrease my velocity, and move slowly, very slowly, and I even can move like this inside a very crowded place to pass through many people around me. Okay, so what is this? I will refract near to the normal because I'm entering a very crowded place. Okay, please, this is very important. While I'm moving from the air, which has a low optical density, and I'm going to enter to the glass, which is a place or a medium with a high optical density. I will refract very strongly. I will go toward the normal, So the angle here, the angle of refraction will be what will be smaller than the angle of incidence. The angle of refraction will be smaller than the angle of incident. I will refract toward the normal, near to the normal. So while I'm moving from the glass, high optical density to low optical density media. So now I will refract away from the normal. I have here a lot of free spaces. I can refract away from the normal, and here the angle of incident will be smaller than the angle of refraction. But what will happen in the third case when it's perpendicular? The light will fall perpendicular between the two transparent medium. In this case, no refraction will happen. No refraction will happen at all, and the angle of incidence and the angle of refraction will be equal 0. No refraction, no angles, both are equal 0. Okay, all of these sounds are of a uniform frequency except the sound of uniform frequency. All violin, guitar, yes, excellent. It's the loudspeaker. It's a non-uniform frequency. As the velocity of the rotation of the gear in Savoart's wheel decrease, the frequency decrease. Consequently, the sound, what will decrease to? Mean antimo frequency, the pitch. Excellent. The frequency of the sound produces from a plate touching a gear of 20 teeth of the Savoart wheel when the wheel rotates 300 cycles per minute. The time should be in seconds. Equals what hertz? So it will be 20 times or 300 times 20 over 60, because I will change this minute into seconds, so it will be over 60. The answer will be 100 hertz. Increasing the thickness of the transparent medium, I will add a lot of transparent papers above each other. The quantity of the light passed through them will decreases, of course. The quanta of what color has the lowest energy? The quanta of what has the lowest energy? I said that the energy direct proportional with the frequency. So I should find the lowest frequency, and it will has the lowest energy too. Lowest frequency, lowest energy. Which color has the lowest frequency? It will be the first one. Lowest deviation, lowest frequency, which is the red color. The human skin is considered as what medium? It's opaque, of course. The light refraction is due to the difference in what? Through different medium, through the light velocity. Okay, the angle of incidence of the light. What is the angle of sorry. The angle of incidence of light is what? Its angle of reflection. It's equal, of course, equal to type. When a light ray travels from air to the water, air, low optical density, to the water, higher in its optical density. So crowded place, I will move like this to avoid the people, to pass through the people. So it will refract near to the normal. The absolute refractive index of any material is always more than 1. As we said, it's the velocity of the light through the air over the velocity of the light through any transparent medium, other transparent medium. So the bigger number will be up and the lower will be down. So the answer will be always greater than 1. A regular reflection happens when the light ray fall on regular wooden, no, it will be irregular. Piece of leather, irregular. Stainless steel sheet, yes, it will be regular. So now please let's draw this together. Complete the path of rays in each of the following figures according to what is written below. Type, for example, I want to determination of the angle of the reflection of the ray in matter Y. So this is the incidence, this is reflecting surface 1, which is called X, and I will draw, for example, like this. Will fall on the other reflecting surface. Okay, let's complete the drawing. Let's draw a normal here for this ray. It will be reflected on the other side like this. طيب هو عايز ايه بقى؟ عايز the angle of reflection. This one, it's between the reflected light ray and the normal of the ray in mirror Y. طيب here is the angle of incidence, and here is the angle of reflection, and this is 40, so this will be 42. This is the first low one. Type. And the normal would be always what? Right angle between it and the reflecting surface. If this is 40, so this will be 50. We have here also a right angle. This is a right angle too, and this is a right angle too. It's very easy. We have another right angle or 90 degree between the two normals. I can find it from here. If I have 40, and this angle would be equal 40 plus 90. And what is the summation of the angles in this triangle? It will be 180. So this is very easy way. 40 plus 90, both of them equal what? Okay. And the value I will subtract it from 180. Okay, so this is 40. This is 90 degree, and I want to find this. This will be 130, 180 minus 130, so the answer will be 50 degree. This angle will be 50, so this angle will be 50 also, because the incidence equal the angle of reflection. I think it's very easy and very interesting. I love doing this. I love solving the problems about the light reflection and refraction. Type this another problem. Let's complete the path of the light and to find how calculate the angle of emergency from point X, given that the optical density of the air less, of course, than the plastic. So low, I'm going to move from low optical density to higher optical density. Let's complete, for example, the drawing of the normal, and then I'm going to move like this, because I'm going to enter in a place with a high optical density, very crowded place, and I will decrease my velocity too. So it will be refracted. So I must draw in it a little bit like this. Okay. This point is not in the right place, but we know, all of us should know, that it will be refracted near to the normal, because I'm entering in the transparent plastic, which is more, has more optical density than the air. And then let's complete. Let's draw the normal here. It going out to the air again, so it will reflect away from the normal. It will reflect away from the normal. Let's make it like this to make it more clear. So it will intersect here. This is the point of emergency, and it will refract away from the normal type. This is the angle of incidence. This is the angle of incidence, and it's always equal what's the angle of emergency. So this is 50, and this will be 50 also. This is very easy, ladies and gentlemen. A minute, please. Okay. Now let's talk about the last unit, inshallah, and it's the reproduction and continuity of species. First, reproduction in plant. We have two types, sexual or asexual. Sexual You must to have a flower, because inside the flower you can find the genital reproductive system, or the male and the female reproductive systems. Right. Let's take a look on the structure of a typical flower. For example, here we can start the thin part, we can call it the pedicle. The pedicle. A minute, please. Okay, here is the pedicle, and here is the swollen part above the pedicle. We call it the receptacle. Okay, and then we can find the first whorl, the first layer, the first whorl. The typical flower contains 4 different floral whorl layers. The first whorl, we can call it the calyx, which consists of sepal, calyx, sepal. The second whorl, which is the corolla, which is consists of petals, and the third whorl, which is the androecium, consists of stamen. The stamen consists of 2 parts. It's the anther, and the filament. Here is the filament. And the last whorl, we have the gynoecium. Okay, it consists of carpel. The basic unit is the carpel, and it consists of 3 parts: stigma-style ovary. The androecium is the male reproductive organ, and the gynoecium is the female reproductive organ. Okay. As we said, for reproduction in plant, we have 2 ways, sexual or asexual. Let's complete sexual first. Inside the sexual, to complete the sexual reproduction, two process must to be finished. For example, first it will be the pollination and then fertilization. The pollination, we have 2 types, 2 ways: mixed pollination or the self-pollination. Let's talk first about the self-pollination, which is transfer of the pollen grain from the anther to the stigma of the same flower. This is self or auto-pollination. What's the mixed pollination? It's the transfer of the pollen grain from the anthers of a flower to the stigma of another flower, but of the same kind. So we can understand from pollination, it's only the transfer of the pollen grain from the anther, okay, to the stigma of the flower. If it's the same flower, I can call it the self-pollination. If it's a different flower, okay, or in a different plant but in the same kind, it will be the mixed pollination type. And we have the third type, the third way the pollination can happen. It's the artificial way. So we have pollination, we have mixed we have the pollination, we have the mixed way, the self-pollination, the mixed pollination, and the artificial pollination. The artificial pollination, it happens by the hand of a man. So we can call it the artificial, and it can, for example, happens for the palm tree. Okay. The mixed pollination also can happen through different things, for example, like the wind or the insects. Okay, the air can move the pollen grain from one plant to another, or the insect can, the pollen grain can attach or adhere to the body of the insect and will move from the anther to the stigma of another flower. The second process to finish the sexual reproduction in plant, it's the fertilization. Inside the fertilization, we have the germination of the pollen grain. يعني for example, first خلاص حصل pollination, pollen grain اهي, and it's at the top of the stigma. Then the pollen grain will going to germinate, produce the pollen tube, and the 2 male nuclei will move down through the pollen tube to reach the ovary, and to go inside the ovary to reach the ovum, the egg cell inside the ovary, which is the part in the female reproductive organ flower. So the pollen will move down, 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 down. The two male nuclei, which was inside the pollen grain, will going to join, will enter from this opening, which is called the microbile, entering in the ovum, entering inside the ovule to reach the ovum, which is the egg cell. Then they're going to fuse together and we're going to make a multiply division, okay, starting from the zygote, and then we're going to divide a lot to form the embryo, and then a new plant will going to be formed. So the ovary that contains only one ovule gives a fruit with a single seed, as olives or peaches, and the ovary that contains more than one ovule gives a fruit with many seeds, as what, as beans or beans or peas and tomatoes, for example. يبقى according to the number of the ovules inside the ovary, we can find the seeds inside the fruit. Reproduction in plants for the second type, which is the asexual reproduction, it's called the vegetative reproduction also. We have two ways, natural or artificial. What about the natural? Natural vegetative reproduction by rhizomes, corms, tubers, bulbs of shoots, but we're going to study only one type of these five. 1, 2, 3, 4, 5, yes, 5 types, which is the tuber. The tuber, it can be the root as sweet potatoes or stem as potatoes. Reproduction in plant, the reproduction in plant, the asexual, the vegetative organ. خلاص, we finish it. Now let's talk about the artificial way, which is by cutting, grafting, tissue culture, or layering. We're going to study 3 of them. Cutting first, it can happen to grapes, rose, and sugar cane. It's like this. We can find any piece from the plant, but it should contain many growing buds. We can call it, we cut it from the main plant and we call it the cut, and we're going to plant it in another pot or in another soil. Part of it will be under the soil and it will grow to form the root system, and the parts above the soil, it will going to grow to form the shoot system, and we will going to have another plant. So this is the reproduction, vegetative reproduction, artificial way, which is called the cutting. What about the grafting? The grafting, it's the way that we can take the sign from a plant and we will going to put it inside the cleft. We made it on the stalk of another plant. We can put it together, tie them together, and this is the grafting by wedge. This is grafting by wedge. And what about the grafting by attachment? It's taking the sign also from another plant and tied it in the stalk in the plant, already the main plants present inside the soil. But this differ in the way of cutting. This is by integrated angle together, and we're going to tie them together. So by grafting, we have the wedge and attachment. Wedge, it's the sign will be inserted to the cleft, which we made it inside the stalk, but the attachment, it's the sign and the stalk will be in integrated angle to each other, and we're going to tie them together. Why we should do this? Because the sign need the juice of the stalk to feed on it and to grow. Okay, so this why we tie them together. And then we will going to talk about the tissue culture. Tissue culture, it's the process, it's the modern way of reproduction, and it's the process of multiplying small part. We can take only a small part of the plant to get many identical other parts. So this is very, very economic and modern way that a lot of scientists use it in our days. Tissue culture. We're not going to talk about anything about the layering. So for the artificial asexual vegetative reproduction, we talked about cutting, grafting, and tissue culture only. Okay, let's talk now about the reproduction in human. Reproduction in human. Let's talk first about the male system. The male system. Okay, please, all of you look to this figure. we have four main parts for the male reproductive system, which is first, we have here, please concentrate. We have a side section, So here we have two testes, but in this figure we can see only one of them. Okay, so the first main part in the reproduction in human, we have what? We have the two testes, and then coming out from it a very long tube. Okay, we can call it the two vas differences. It would going to be inserted inside the urethra. Okay, and then the third part, we have what? The associated glands. It's the glands. Any glands, some must secrete hormone or must secrete something. So we have three, which will going to help a lot in the male system. Okay, so what are the names of these associated glands? We have the seminal vesicle, we have the prostate glands, and we have the Cowper's glands. We have two also Cowper's glands. Right. This is the third part. What about the fourth main part, which is called the penis? It's called the penis. Right. I want you to understand something, yeah, shabab. This part, the ureter, the bladder, and the urethra, it's part from the urinary system. Urethra, the ureter, the bladder. The urethra is a common duct between these two systems, the urinary system and the reproductive system. As you can see that the vas difference will going to be inserted in a part in the urethra. Also, the associated glands will have an opening or will be inserted, will secrete something and will be inserted or poured inside this urethra. So the urethra, it's a common duct between both system in male system, in the male and the male reproductive system and the urinary system. So the first part I talked about, it was the testis. This is the testis, and we can find a very important thing about the testis. It's oval shape or elliptic shape, okay, and it's also a gland. So we're going to find that it will produce the sperm and secretes hormone, which is the secondary male sex hormone, which is called the testosterone. And it's protected and be outside the body in a sac called the scrotal sac or the scrotum. Why, subhanallah, this test is kept outside of the body in this scrotal sac? Because this sac will regulate and keeps the temperature 2 degrees below the body temperature, which is the perfect and the optimum temperature for the production of the sperms and for the growth development of the sperm too. Okay, and as we said, it will produce the sperm and the secondary sex hormone for the male, which is the testosterone. What's the function of the testosterone? It's the secondary sex hormone for the male, which is helps in the signs that will appear in the puberty in the male, and al-bulugh, signs of puberty in male, which is growth of the hair in certain body areas like the beard and mustache, harshening of the voice, growth and development of genital organs, growth of the bones, enlargement of muscles. Okay, the signs of the puberty in male, which is this is the function of the secretion of the testosterone. Okay. Secondly, we can find the vas differences, the two vas differences, one in this side and the other in the other side. The vas differences will start with overlapped convoluted part above the testis, which is called the epididymis. The epididymis will be extend into one tube, and this one tube will call the vas difference. The vas difference, epididymis first, okay. And what's the function of the epididymis? It will what will happen inside the epididymis? It's the last stage of development and growth of the sperm, okay, and it will store the sperm inside it. So we have two functions: the store and the last stage of the development of the sperm will happen in the epididymis. Okay, type. What about the vas difference? Only the vas difference will transfer the sperm from the testis to the what? To the urethra, the common duct I talked about. Okay, so the vas difference will transfer the sperm from the testis to the urethra. Okay, the third part, sorry, in the male reproductive system, the third part, it's the associated gland. We have, as we said, seminal vesicle gland, prostate gland, and the two Cowper's glands. All of them insert something, pour a fluid inside the urethra, which is called the seminal fluid, What's the function of this seminal fluid? First, the sperm will feed on it, facilitates the movement of the sperm through the urethra, and the most important thing the seminal fluid can do, which is the neutralization of the urethra. As we said, guys, it's a common duct between the urinary system and the reproductive system. So the urine path also in this common duct, which is the urethra, which is the urine has acidic effect on this area. So how to neutralize them, to make it neutral, to not affect the sperm while it's moving through it? By this seminal fluid. This seminal fluid will neutralize the urine effect inside the urethra, so the sperm can move inside the urethra without any effect on it. And the last part, which is the penis. The penis is a sponge like shape, which is the urethra moving inside it. And here is the semen collected and be secreted with through the opening, which is called the urinary genital opening. Okay, and the urine also come from the same opening, but never ever at the same time. This is a very important note, that what are the reasons that led to the occurrence of sterility, infertility in male human? First, the testes do not come out of the body cavity during the development of the embryo, so the sperm will not going to be formed. So this male that we are talking about will become infertile. Second, the occurrence of a cut in the two vas difference. So also the sperm cannot move from the testis to the urethra. So this man will be infertile too. The third point, the inability of the sex glands to secrete the seminal vesicle. So the sperm will go to die by the effects of the acidity of the urine coming out and moving in the same duct, which is the urethra. Now let's talk about the female reproductive system, which is also, yeah, shabab, consists of how many main parts? 4 main parts. It will be the 2 ovaries, the 2 fallopian tubes, and 1 uterus and the vagina. First, let's talk about the ovary. The ovary, it's a gland, so it must secrete something, and it contains what? The ovum, which is carrying 23 chromosomes only, okay, as the sperm is carrying the another 23 chromosomes to fuse together to form the zygote to be 46 chromosomes. And it's like, what's the shape of the ovary? It's like a build element. Its place, lower abdominal, okay. The function of the ovaries, it will going to contains and produce the ovum, plus it will going to secrete 2 hormones, which is the progesterone. Progesterone is very important to maintain the continuity of the pregnancy, and the estrogen, it's like the testosterone in the male reproductive system, which is the responsible for the secondary here female sex characters. And of course, the ovulation process, the menstrual cycle, will happen or starts in the ovary, as the ovary will produce, each ovary will produce 28 days one ovum will coming from one ovary, and this will going to be alternative. Yani one ovary, and the next month, after 28 days, then another ovary will going to produce the second ovum. So ovulation process, it is the process of production of ova, where each ovary releases one ripe ovum every 28 days in exchange with the other ovary. Okay, this menstrual cycle will going to start at the age of 11 to 12 years, ends 45 to 55 years, and here we will call it the menopause phase or stage. So we will going to have, for example, 35 years to produce the ovum. That the number of the ovum that can be produced through 35 years will be 555. I'm very sorry, give me a minute. 455 ovum. Okay, right. What about the estrogen? The estrogen and the secondary female sex character that can be appeared due to the secretion of the estrogen. It's the sign of puberty in female. The first one, growth of the hair in armpit and pubic, softness of the voice, growth and development of breasts, accumulation of fats in some body regions, occurrence of menstrual cycle. Okay, طيب. Okay, let's talk about the third main part in the female reproductive system, which is it's the second. It's the fallopian tube. That fallopian tube is going to, can you see here from this picture? It's like a finger-like projector to take the ovum from the ovary. Okay, inside this fallopian tube we can find a very small hair, we can call it the cilia. This all of these features of the fallopian tube help a lot in taking and trapping the ovum, and to facilitates the movement of the ovum inside the fallopian tube till it reaches to the uterus. Okay, and also they can contract and relax. All of these features can help the movement of the ovum inside it. And then the uterus here, you can find this the pear-like shape in the middle. Here you can find, if you're going, or this female is facing up, we're going to happen, the pregnancy will going to happen, the ovum will going to be implanted inside the ovary, stay inside the ovary, and going to form the placenta, and the placenta, the fetus will going to feed from it through the umbilical cord, So what's the placenta? Develop it in the uterus. It's a mass of blood vessels which connects developing the fetus to the uterus wall to allow the nutrient uptake and gas exchange via mother's blood vessels. It connects to the fetus via the umbilical cord. And finally, the last part will going to be the vagina. The vagina, it's the liver coming out. When the time of the labor, this will help a lot to the baby to come out from it. Types of cells. We have the somatic cells, like the cells in all of your body, muscles and skin. The other type will be the reproductive cells. It's like the ovum and the sperms type. What are the difference? It's the difference between the ovum and the sperm and the other somatic cells. The difference, it's the number of the chromosomes in both. Yani, for example, somatic cells, muscles and skin, they contains 46 chromosomes each cell, but the reproductive cells, which is the ovum and the sperms, which contain half the number of the chromosomes, which is 23 only. Here is the shape of the ovum, and there is the shape of the sperm. The nucleus here, when I'm talking about the ovum, that contains 1/2 of the genetic material, 35 chromosomes. It contains the cytoplasm after the nucleus, or the nucleus in the middle of the the cytoplasm that contains the stored foods and nutrients that are surrounded by the plasma membrane, the cellular membrane, and intact membrane that surrounds or coats the cell from outside. So I have the uterus, cytoplasm, the plasma membrane, and then after it, the cellular membrane. What about the sperm, the structure of the sperm? The head that contains one half of the genetic material, 33 chromosomes. The midpiece, this piece, it contains the mitochondria, which is responsible for the energy production need for the sperm to be mobile cell. The tail is the thin and long, and it is responsible for the movement of the sperm till it reaches the ovum. Let's talk about the fertilization, how the two fuse together, the sperm with the ovum, to form the zygote, which is the complete number of chromosomes here is present, 46 chromosomes. Steps of the fertilization. It's a very summary for the part of the fertilization. The sperm secretes a material. خلاص, already the sperm reaches the ovum. Okay, it will secrete the material, dissolve the wall of the ovum, penetrating it. The ovum now خلاص enclose itself by a membrane to prevent any another entry from any other sperms. Nucleus of the sperm and the ovum fuses together to form fertilized ovum, which is called the zygote. That contains a nucleus with 23 pairs of chromosomes, and then the multiply division will be formed to form the embryo. So here you can see this is first day, second day, the third. At the end of the first week, implantation of the zygote will be in the uterine lining. Okay, here is the sperm with the chromosomes inside its nucleus, and the chromosomes inside the ovum nucleus too will be fused to form the zygote, which is the fertilized ovum. Fertilization in human, it is the fusion of the nucleus of the male gamete, the sperm, with the nucleus of the female gametes, the ovum, to form the zygote fertilized ovum. What about the pregnancy period? It is the period between the fertilization process and delivery, which extends for about how many? Of course, 9 months. The fallopian tubes, lignation, tie up the fallopian tube surgically, of course, is considered one of the means of a birth control. Let's solve some exercises here. The opposite figure shows a flower being pollinated by wind. Okay, air. Write the label for each of the X and Y. Yani, for example, X will be the anther, excellent. Y, it's the feathery stigma, and we're going to notice that this two factors is very important if the pollination will happen by the wind or the air. Okay, the anther hangs outside, and the stigma is feathery stigma. Type. Mention two characters that make the flowers pollinated by wind. Okay, the one anther are hanged in air, as we said, to be easily opened by the air. And the stigma, okay, can be feathery to attach any pollen grain from the air. The stigma is feathery-like and sticky to catch pollen grain from the air. This is great. Type. Explain how cross-pollination happens in this flower. How cross-pollination happens in this flower. The stigma of the flower catch the light. Okay, this is a very important character for the pollen grain also that can be carried by the wind, to be dry and light in weight and huge in number. So light and dry pollen grain carried by the air from the anther of another flower to in another plant of the same kind, must be of the same kind. This is the definition of the cross pollination type. Mention the sex in each flower from the following. Here we have how many whorl? We have the first, the calyx, the corolla, andrecium and gynoecium. So this is unisexual, and this we have all three. And which part is missing? It's the andrecium, and we have the gynoecium. So this is sorry, this is bisexual. I'm very sorry. Number one, bisexual, hermaphrodite bisexual. The second is unisexual, female unisexual plant. And the third picture, you don't have the gynoecium, we only have the andrecium. So we have what? The male unisexual flower. Right. Let's please write the thing which is represented by each of the following figures, label each of the following. Yani, for example, what is this? This is a germinated pollen grain. Excellent, or the germination of the pollen grain. Type. What is number 1 here in this figure? It's the pollen cell itself. And number 2, it is the two male nuclei, the 2 male nuclei that we are in need for them to reach inside the ovary, to enter in the microbial and to join to the or fuse to the ovule. Type. Figure number 2, it is of course the male reproductive organ. Number 3, it's what? It's what here? It's the seminal vesicle. Not this the cowpers, this the seminal vesicle, and this the black one it's the prostate. So this the seminal vesicle, okay? And number 4, this is the testis. Figure 3, it's what? It's the grafting by which. It's the grafting by which. As you can see, this is 5, the sign, and this is the stalk, and it's the stalk is inserted in the cleft of the sign is inserted in the cleft of the stalk. So this is grafting by which. Okay, ladies and gentlemen, please concentrate. It's the last slide, inshallah. Okay, the flower arises from a floral bud. Excellent. Yalla, help me. Which emerges from the axil of a leaf is called the bract. Bravo. The corolla attracts insects to the flower, which helps in pollination. Bravo. Types of pollination are يا إما self or auto pollination, يا إما cross or mixed pollination. After fertilization, the ovary grows, forming the what? While the ovule converts into wild. This is very important part. After fertilization, the ovary grows, forming the fruit. Okay, and the ovule will be converted into the what? The seed. The cut is a part of maybe the root, the stem, or the leaf that containing what? Very important, growing buds. Excellent. Type. The human male genital system consists of 1, 2, 3, 4 main parts. As we said, first, the 2 testes, the 2 vas deferens. My handwriting is terrible. Excuse me. And we have the associated glands, and finally we can find the penis. Type. The testis function is to produce what? To produce what and to secrete what hormone? Produce the sperms and secrete the testosterone hormone. The female genital system consists of 1, 2, 3, 4 also main parts, which is the 2 ovaries, the 2 fallopian tubes, and we will find then the uterus and then the vagina. This is the 4 main points. What hormone is male and what hormone is female are responsible for the appearance of the secondary sex characters. The male, it's the testosterone, and the female, it's the estrogen. Okay, here also in the testis function is to produce the sperms and secretes. We can write here the testosterone hormone or the what? The secondary excellent sex hormone. You can write this or that. Both are right, inshallah. Okay, ladies and gentlemen, we reached to the end of our session. I hope that all of you understand everything that I said. I hope that everything is clear for you, and I hope the best of luck for all of you, ladies and gentlemen. Okay, and inshallah we're going to see you a lot again. Okay, bye bye.